Wait, I think we're missing some parts of this story. How did we get to this point? Well, anyways, howdy, I'm Leon, and today I'll be exploring game theory and artificial intelligence concepts in the card game Yusef. Yusef, or commonly called Yaniv, is a card game that involves 2 to 4 players using a 54-card deck, the standard international deck with 2 jokers, where each card is worth their respective face value. An ace is worth 1 point, royals are worth 10, and jokers are worth 0. Players are dealt 5 cards randomly and play in a clockwise order. The remaining cards form a drawing stock in the middle, where the top card of the stock is turned face up and placed alongside to start the dump pile. The players look at their cards, and one player is randomly selected to start. On a player's turn, they must place a card down in the dump pile, but have the choice of picking up the top card of the dump pile underneath their newly placed card, or draw a random card from the drawing stock. The player can place sets of cards, for example, pairs, triples, quadruples, or 3 or more cards in a sequential order with the same suit, which we call a straight. No matter how many cards the player places down their turn, they will only pick up 1 card per turn, which will result in less cards in their hand if they put down a set of cards. Therefore, a player will have at least 1 card and a maximum of 5 cards in their hand. Note that a joker counts as any card required for a set. If the drawing stock is empty, the cards in the dump pile except the top card will be shuffled, replacing the drawing stock. Instead of putting down cards, a player can choose to call Yusef, which ends the game. A player will only wish to end the game if they are relatively confident that their hand has a lower sum of points than their peers' hands. All players' hands are revealed and the sum of their cards' points are tallied. If any player has a sum less or equal than the player that called Yusef, the player that called Yusef will acquire the sum of all the players' points. Otherwise, the player that called Yusef will acquire 0 points, while the rest of the players will acquire their respective sum of points of their hands. To simplify things, the object of the game is to score as little points as possible. For the sake of simplicity, we'll assume the player can only call Yusef when they have 5 points in their hands or lower. Yusef is a card game that is partially observable, which means that there is uncertainty about the state of the system, as not all cards in the deck and in the hands of other players are visible to a player. Yusef is also stochastic, which means that there is unpredictability of actions due to a random element, which can be seen in choosing to draw a card from the drawing stock. So how does this relate to artificial intelligence? When we think about artificial intelligence, we think of robots taking over the world. But with inspiration from John McCarthy's definition from the 1950s, we can define artificial intelligence as the science and engineering of designing and creating intelligent agents, where an intelligent agent is a program that can make decisions and perform a service based on its environment, user input, and experiences. Think of an intelligent agent as a system that attempts to make rational, intelligent decisions as a response of percepts or responses to its environmental inputs. So could we hypothetically create an intelligent agent that could play the card game Yusef? What would be the goal of this game? To score the least amount of points possible, so an intelligent agent that plays Yusef would attempt to make rational decisions in order to lead to the best conclusion, or the least amount of points in their hand. An observation I noted from playing this card game was that there were several decision points during a turn. Firstly, should one call Yusef? This relies on whether one can call Yusef in the first place, if they have reached the requirement of 5 points or less in their hand. Nextly, what card should one place down? Let's assume a heuristic where the best move is to remove the most amount of points from their hand. Therefore, one would often remove sets of cards because their sum points are often greater than the points of a single card. This would be the safest decision, as another player could call Yusef at any time. However, this is ignoring the intimidation factor that is caused by having less cards in one's hand that affects other human players, who assumes that less cards in one's hands means less points. Finally, should one pick up the face-up card from the dump pile or draw a random card from the drawing stock? Although as a person I could not reasonably memorize cards or count cards that have been revealed by other players, An artificial agent can and will utilize card counting to build its knowledge base. With knowledge of what cards have been played and what other cards can possibly comprise the drawing deck, an intelligent agent could roughly calculate the probability that drawing a card from the drawing deck will produce a card that has an equal or less number of points than the face-up card. Assume we utilize this simple heuristic. Therefore, the probability is favorable to a certain degree. An artificial agent will choose to draw the random card. However, this does not factor in knowledge of other players' cards, assuming they have picked up visible cards, and the probability they may call Yusef. As the player goes on during the game, it becomes more viable to choose safer choices in lieu of riskier choices, even if the riskier choices can benefit more in the future. Although this video was not able to get into deeper AI concepts such as expected minimax trees or Monte Carlo tree search that can be used to solve this problem, I hope it served as a proper introduction to how artificial intelligence concepts can be utilized and applied to things that we are familiar with to a certain degree. As AI continues to grow as a field, I'm astounded at the concept of potentially designing and implementing an intelligent agent to play one of my favorite childhood card games. What's left there to discover?